Hello class, today we are talking about linear systems and inequalities. Whenever you're talking about a system of inequalities, you're thinking about you have a situation where you have two or more equations and then two unknowns or two variables. There are multiple methods that you can use to solve the systems of equations. It just depends on how it is set up. So I'm going to talk to you about the different methods and then how to apply them into word problems. So when we're doing substitution, first, you want to isolate a variable. That means get a variable by itself. So looking at our example, the easiest variable to get by itself would either be the x or the y up here. So I'll do my calculations over here. I'm going to get y by itself. So I will subtract x from both ends. And then I'll write it down here. My equation is y equals 2 minus x. After I isolate a variable, I plug one equation into another. So I take this isolated part, I take this piece, and I'm going to substitute it or plug it in for the y in the equation I did not manipulate. So this goes in right there for y. And now I write 2x plus 7 instead of y. I write this. Usually I say we write it in parentheses. After you do that, you solve for your variable. So this is now a normal solving equation. So I would distribute. So 14 minus 7x. And copy down the 2x because that did not change. Now I'll combine my like terms. And I will subtract 14 from both sides. So we have negative 5x equals negative 5. And that means x equals 1. Then I take my 1. And I have to find my other variable, which is the last step. Plug your answer into the original equation to find the second variable. And it actually doesn't matter which equation you plug it into. I usually plug it into the simplest equation, which would probably be the top one. So instead of x, I write 1. So this 1 is going all the way up there. And so that means that y is also 1. And then depending on your situation, a lot of times you will write your answer as a point. And so it's the point 1, 1. Another method or another way to solve a system of equations is to use a method called elimination. I personally prefer elimination to substitution. Let's go through the process. First, you're going to choose a variable to eliminate. It actually never really matters which one you choose to eliminate. So for our purposes, I'll eliminate the x. Make the coefficients the same number, but opposite operations by multiplying one or both equations. So I am allowed to change around these equations by multiplying. I need the coefficient, or the number in front of x, to be the same for both equations. The easiest way to do that is to take this top equation and multiply it by that number, which is 5. Then take the bottom equation, multiply it by that number, which is 4. Then notice it says having the opposite operation. Whoops. Which means that you need to have one of them be a positive and one of them be a negative. So right now these are both positive. So I'll make one of them a negative by making that a -4. And so if I multiply everything in this top equation by 5, it's like I'm doing the distributive property. So 20x minus 5 times 3, so 15y equals 40. Don't forget that last number. A lot of people always forget that one. The bottom equation, I'm multiplying it by -4. This time it's negative 20x. -2 and -4 makes +8. Be careful when you do that. And a -11 times a -4 is 44. Now, add the two equations together. Since everything is written in columns, you just add straight down the column. So 20 minus x is 0. So this cancels, which is what you want to happen. -15 and +8 make -3. And then 40 and 44 make 84. Whoops. 15 or -15 minus 8 is -7, not -3. So then you divide both sides by -7 and pop that in your calculator. 84 divided by -7, y equals -12. So that's half of your answer. The other half of your answer, you have to plug it back in, like into one of the original equations. I think I'll plug it into the first one. So 4x minus 3 times -12 equals 8. Again, this 12 is going all the way up there into the 3. So first I do -3 times 12 times -12. So I have a +36 equals 8 and a 4x here. And then I have 8 minus 36, which is -28. Because I subtract 36 from both sides. And I divide my answer by 4, and I get x equals -7. I have my x, I have my y, and then a lot of times I will write it as a. Now, if you're not comfortable with substitution or elimination, you can always solve it by graphing. Graphing, again, if you're going to graph anything, it has to have a y by itself. So right here, you have -4x plus 5. So that one already has y by itself. So plot your m at 5. 1, 2, 3, 4, 5. And then your slope is down 4. 1, 2, 3, 4 over 1. When you're doing this, you want to fill up your whole coordinate plane. And so those are your dots. And now we'll graph the other line. Now there's two different ways to graph the other line. You can get y by itself, or you can plug in 0. So like if I plug in 0 for y, I get -10, which isn't really helpful because my grid doesn't go to -10. So let's graph that plane. But you can always plug in 0 for y and 0 for x and just plot those two points and connect the dots. Let's get y by itself. Negative equals -x minus 10. Then we got to divide everything by a -1. This is going to be annoying because our grid doesn't go to 10, but that's okay. So on my y-axis, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to plot my points, I have to go up 1 over 1. So technically, I'm going up 1 and over 1 like this. But that is going to take me way up the graph. So I'm going to go down 1 and backwards 1 because that's the same thing. Down 1 and backwards 1. Down 1 and backwards 1. So it appears that these two graphs cross off my grid, which is perfectly fine and perfectly normal. It happens all the time. It appears that the two graphs cross at I'm going to have to do a little bit of estimating here. Looks like they cross at -3, and let's see, this was 1, 2, 3, 4, 5, 6, 7, 8. When you're solving by graphing, you can always put it in your graphing calculator and see where the graphs cross as well. Now we're going to solve a system of inequalities. So the system of inequalities is always the answer is always the shaded part. So this one, this is starting with a b at -2. And then it's going down 1/1. All right. Then we have to make sure we're paying attention to this guy. It's greater than, so we're shading above. And the line is dotted because it's not equal to. So I like to shade like this. Let's see. Now this one, let's go ahead and we'll plug in, we'll do our y equals mx plus b, so we'll subtract 3x. And then I have to divide by -1. Now here's a trick that I didn't remind you of in the last video. Whenever you have an inequality and you divide by a negative, you have to flip the inequality sign. So y is less than or equal to 3x plus 1. Maybe write that down. So this is now a less than problem. We'll worry about that in a minute. So we start at +1, then we're going up 3, 1, 2, 3 over 1. When we're doing this one, we don't really care about where the graphs cross. We care about where the shaded parts overlap. So this is less than or equal to. So that means it's going to be a solid line. And less than, so I'm shading below. So the part where the two shaded regions overlap is this guy. That's technically my answer. A lot of times on the multiple choice questions you see, it'll just have this part boxed. It won't have shading here or here. All right, write down any questions you have, and I'll open up your quiz.